Okay, good morning. My name's Elton. Thank you for joining me. I work for Docker, and this session is all about service mesh. So service mesh is this new technology that's grown massively quickly. It came to prominence really only in the last year or two. It does some really exciting things, but just like any technology, there's a certain amount of investment to learning how to use it and to actually operating it. So this session is about telling you what a service mesh does, but also trying to help you evaluate whether it's something that you want to bring into your next project. So three main areas. I'm going to talk about briefly what a service mesh does, so how it works and the features you get from it. There's a whole bunch of demos in this session, and I'll be using Istio, which is like the leader in the service mesh space. Istio runs on different things, but I'll be running it on Kubernetes. And then I'll be intertwined with that. I'll be talking about how you might want to evaluate this whole approach and whether it's going to fit in with what you want to do. It's a two-speed session, really. It's quite difficult to pitch this because the introduction to service mesh, the concept, is pretty simple. So I think we can all get to that level pretty quickly. But the implementation, because I'm running on Kubernetes, it gets technical pretty quickly. So just a show of hands, if I throw up a Kubernetes manifest, who would want me to go through and explain what's on the screen? Okay, you're out of luck because I haven't got time to do that. So what I will do is I'll focus on the bits that are important towards Istio. Okay, so firstly, what is a service mesh? So this is all about distributed computing. When I've got a software product where the components are in different components that are talking to each other over the network. And what the service mesh lets you do is take that communication between all these pieces and elevate it into its own entity, which you can control and look at as a separate thing. So taking these little bits of logic out of every single component and putting it into a central unit. So a very simple definition is the communication between these components made into its own thing. This is not an official description. This is how I think of it. What you'll see on this description is there is no mention of microservices or Kubernetes or containers. The concept of a service mesh is a network-level infrastructure piece of kit. It doesn't have to work with containers and Kubernetes. So it emerged from the world of microservices because you get the proliferation of components. It's much easier to manage them if you've got this central thing. But you can install a service mesh on a VM that's running a database and a VM that's running a monolithic web app, and you can still get a service mesh between those things. So what does it actually kind of do? So imagine my very simple distributed system here. So I've just got two things, monolithic web app and a SQL database. For the web app to communicate with a database, it needs a bunch of stuff. So at the very minimum, it needs an address of where to find the database. And then all the network communication, actually there's a whole set of behaviors that need to be baked into my web application to make sure that the communication is reliable, because the network itself isn't necessarily reliable. So things like, if I try and connect and I can't reach the database, how long should I wait for? Should I time out after 10 seconds or 30 seconds? What should I do if I time out? Do I raise an exception or do I try again? If there's a transient failure when I'm trying to do a fetch or an update, do I retry? How many times do I retry? What's the gap between retrying? Should I increase the gap after each retry? And then encryption. Do I need to encrypt the traffic between these two components? Is that a requirement from a regulatory basis or just because it's good practice? All that kind of logic is baked into the client inside the web component. So in this case, it might be some sort of SQL client. It'll have its own way of configuring and setting up all that stuff. Maybe some of those features aren't available. So you have to have another client library, something like Poly in .NET, which does the retries for you. So maybe you need to bake all that stuff in. And that's OK, but the trouble is, as soon as you've got another component, so if I've got an API that I also need to talk to, I've got all the same concerns. So I've got all those things that I need to bake in for my API communication too. And this will be a different type of network client. This will be, if it's a REST API, it'll be an HTTP client. So I'll have a different set of features that I need to configure in different ways to deal with this sort of behavior, and a different set of capabilities from that client. So this is becoming difficult to work with because not all these different clients will have the same sets of features. And if I want to make changes when I'm live, I either need to have everything configurable, in which case I need to have a decent configuration system so I can inject changes at runtime, or I need to release a new version of my application, neither of which is going to help me be particularly agile. And it becomes much worse when you've got a microservices architecture. So this is a demo application that's on GitHub. It's just a web application, but it's broken down into these myriad different services. And when you run this, you end up with these 13 different components. Each part of the experience has its own microservice. Stateful services have their own data store. Everything's running in containers. Everything's got that big list of concerns about retries and addresses and encryption. They've all got to deal with that in their own way. So what does it look like when you have a service mesh? So going back to my simple example, when I've got my service mesh, I'm going to deploy these things in some way on some infrastructure. In the demos, I'll be using Kubernetes. So they will run as Docker containers. And then I've got my service mesh, which is a separate thing. So on the same set of infrastructure, on the same cluster, I've got my service mesh, which is a different application that's running. Now, they can be completely independent of each other. It's only when I register my web application with the service mesh, and it becomes part of the mesh, that we can start doing things in an interesting way. What the service mesh does is it injects a network proxy into my web component. So a proxy, just like if you're in a corporate environment and you use your web browser and you go to google.com, it looks like you're going directly to Google's site, but actually you're going through your corporate proxy, which has got a whole bunch of rules about what you are and aren't allowed to visit, and it tracks everything you do and it reports it to your boss. You don't know anything about that. And the client, the browser, doesn't know anything about that. It's a transparent excuse me, network proxy. And it's the same with the service mesh. So the web component is still talking to the database or to the API, but all the traffic is being routed through this proxy, which means all the logic that I care about can go into the service mesh. So my web component, when it makes a call to the API, it just makes a call to HTTP//API. And then the service mesh says, this connection from the web to the API, that actually the real address should be whatever. And for this particular communication, the timeout is X, the retry policy is Y. All that logic is centralized in the service mesh, and it applies to any type of communication. It doesn't matter whether it's talking to the database or to the API. I can apply the same sets of rules with the same sets of features all in the service mesh. OK, let's go back here. And of course, I can also apply that to external traffic. So if I go back one, if I control all these components, then I can register them all with the service mesh, and I can have all those capabilities for everything that's connected with them, and also on a server side. So from the client side, I can say, here's my timeout policy, here's my retry policy. From the server side, the communication is coming into the API, I've got another set of features like rate limiting and throttling. And again, I can apply all those from a central level. And for communication that's coming from the outside, I can register the kind of a gateway with my service mesh, and that's owned by the service mesh too. So all the traffic that's coming into my application goes through the same sets of rules and policies as the intra-service communication. OK, so that's the broad picture. Now, Istio is the kind of leader in this space because it has the biggest feature set and it's been the most mature. It's a fairly new product. So, I've gone the wrong way, excuse me. It's open source. It's platform agnostic with a fairly big asterisk because there's only a few platforms that it actually works on, some much better than others. It's new. It didn't emerge until 2017, and it went GA kind of last year. But it grew massively popular really, really quickly because it solves all those hard problems in such a nice way. Other service meshes are available. So Consul from HashiCorp, who do Terraform and all the other great stuff, that's something that you can deploy outside of Kubernetes, and you can just run them on virtual machines. And then Linkerd, it looks like Linkerd, but it's Linkerd, is something that also works nicely with Kubernetes. It offers a similar set of features. We're kind of going to get to the point where there's a superset of service mesh features that they all apply. But at the moment, Istio has the best set. There are three areas where Istio kind of gives you a bunch of features. And the first is with traffic management. So because all the communication for all your components is routed through Istio, Istio can control what happens with that communication. So things like service discovery is the obvious one. So I can be talking to my API. I don't need to have any kind of configuration system to say, in dev, the API is on localhost, in test, it's on X, and in prod, it's on Y. All that's going to be logic inside Istio. But also, it can do load balancing. So if I've got lots of deployments of an API component, Istio will load balance between them. And it can do the failure handling. So not just simple things like retries, but it can do more complex things like a circuit breaker. So if the call to the API fails, then it will try again, and then it will back off gradually, so I don't get this cascading failure. The second area is security. So we're kind of, hopefully, getting to the position where people don't trust their internal networks anymore. So there used to be this pattern called trusted subsystem that meant once the network's in my once the traffic's in my network, it's fine. Everything can talk to everything. And the trouble with that is that that's not a secure way of doing things. So Istio gives you security in depth between these components. So it can encrypt all the traffic from the web component to the API and vice versa. It uses mutual TLS. So each component has its own SSL certificate, and it does an exchange to make sure that you're only allowed to send traffic in if you're an authorized client, like an authorized service client. And it can do authentication as well. So that could be authentication to say, I am the web server, or it could even be end user authentication to say, I am Joe Bloggs. And the last one is about observability. Again, because everything's going through this mesh, Istio is watching everything. It can tell you what's going on, and it can give you a level of observability that you can't easily get otherwise. From as simple as just visualizing your whole landscape and showing you what's talking to what, right down to individual log elements to say the web component made an HTTP call to the API component. This was the URL, this was the response code, this is the amount of time it took. It can do all that stuff for you. Okay, I said it kind of platform agnostic. Actually, it works best with Kubernetes. So it emerged from the world of Kubernetes. What Kubernetes does, as well as being a container orchestrator, it has a huge amount of extensibility. So Kubernetes, the API, can manage all its own resources. So things like pods and load balancers, and if you don't know what any of that stuff is, don't worry. Kubernetes looks after its own stuff. But you can register your own custom resources and have Kubernetes manage that for you. So if I'm Istio, I can deploy the things that I care about and tell Kubernetes to manage them for me. And then as a user, the way I deploy my Istio configuration is by deploying a Kubernetes manifest. So I'm working with the same type of technology. It uses a third-party open source component called Envoy for the actual proxy that does the network calls. That's like a native binary that's optimized to be a super fast proxy. So really, we're in the world of Linux at the moment. So Windows support for Kubernetes has been in beta for a little while. Hopefully, it will GA in the next release of Kubernetes, which will be March, April time. Envoy and Istio, when they come to Windows, will be further down the line. So at the moment, this is a Linux stack. OK, and this is what things look like when you're running them in Kubernetes with Istio. So imagine I've got service A and service B. Now, without a service mesh, service A talks directly to service B, and everything that I want to happen with my network behavior has to be baked into the logic in service A. I can deploy Istio, and Istio lives inside Kubernetes as a bunch of Docker containers. So there's a bunch of pods that are running these different components of Istio that are just sat in my Kubernetes cluster, and until I explicitly allow it, it doesn't really affect what's happening with my application. But when I register my services with Istio, that's when everything goes through the proxy. So Istio injects this proxy component into my application component. The way it does that in Kubernetes is that service B is a container living inside a pod, and the proxy is in a separate container inside the same pod. So the network communication is completely transparent. Service A just makes a call to service B, but it's being routed through the proxy. What those proxies do is they talk to these different components of Istio to apply the policies that you've specified. So all these different things it's all on the Istio repo on GitHub. Pilot is the thing that pushes configuration data out to Envoy. Mixer is the things that actually applies the rules. And then Citadel is the security component that issues certificates, rotates them, and does all that sort of stuff. Go back here. This is all fine, but if I'm a developer or an operator, the only thing I care about is service A and service B. So that's my application. That's the things that I care about. And there's an iceberg-style, huge amount of stuff going on under the covers in order to get service A talking to service B through the service mesh. So that's the first thing to bear in mind. This stuff is not free. Like, it's an open source component. You drop it in your application. That's all fine. But there's an awful lot of technology happening to make your service communication go through the service mesh. So for your My First Microservices app that just returns hello world in a JSON string, so if I've got my single line of code, if I'm deploying it to Kubernetes through Istio, then there's like 6 million lines of code in the platform underneath it before I execute my line of code. These things have different release schedules. They have different teams working on them with different priorities. So if you're gonna take this stack into your production, you need to think about when there's an update to Istio, do I need to apply that? have I got the right version of Kubernetes to work with the latest version of Istio? Do I need to do a Docker upgrade as well? Do I need to upgrade all these things independently? And how do I test it and all that sort of stuff? So just bear that in mind. OK, so the demos I'm going to show you use a demo application from the Istio product itself. So all the source code is up on GitHub again. It's a really simple product page that tells you stuff about books. It's delivered as microservices, so all the requests come into a website that shows you stuff about a book, but the details come from the details microservices, and then people can put reviews in about the books they're reading. And so there are 3 different implementations of the review service that each have a different UI. And then some of them go to a rating service which stores things in a database for being rated. I'm going to focus on when you deploy this with Istio. So I can deploy this in Kubernetes, and it will work. And I can deploy the exact same application manifest with Istio. And Istio adds an Envoy proxy into every single component. And right at the beginning there's a gateway component that monitors the traffic coming in. When I'm deployed with Istio, now I can control all the traffic between everything else. Prior to that, I've got 3 implementations of my review service that could all be deployed on the same host name. So they're all going to be available with a service called reviews. So when I start sending traffic them, it's just going to randomly cycle between them. Kubernetes will do the load balancing for me. When I deploy with Istio, then I can control what happens for that area there. And that's the bit I'm going to focus on. So all my demos will be between the products and the reviews. OK, so using Istio, this is the first demo. I'm going to deploy Istio. I've got a fresh, empty Kubernetes instance. I'm going to show you what deploying Istio actually looks like. That's a one-time thing. Then I'm going to set it up so that every single application I deploy through Kubernetes automatically registers with Istio. So you can do it manually. So I can say, here's my application manifest. There's some stuff in here to tell Istio that I'm registering these components. Or you can have it happen automatically. So every new thing that gets deployed to Kubernetes, the Kubernetes API talks to Istio. Istio says, right, I'm going to register these services. So they all become part of the mesh automatically. And then I'm going to deploy this sample app. OK, so demo time. So I'm running Windows. I've got Docker Desktop installed. And Docker Desktop comes with, you can switch to Windows or Linux containers. I'm in Linux container mode because everything is going to be Linux-based. And you can spin up a single-node Kubernetes cluster on your laptop. So Docker Desktop for Mac and Windows, you get the same thing. So I have here, just check, I've got the latest version of Docker, which is 1809. And if I clear this down and check Kubernetes, I've got version 113 of Kubernetes, which is the GA release. So this is a single node cluster running on my laptop. Now, if I want to deploy Istio, the first thing I need to do is deploy these custom resource definitions, these things that Istio understands, but Kubernetes will manage for me. All this stuff, incidentally, is mostly from the Istio docs. I'm not doing anything particularly clever here. So the first thing is to deploy these custom resource definitions, which tell Kubernetes about Istio objects, like destination rules, which say where traffic's going to go, with virtual services, which is how Istio manages shaping traffic around. So I'm going to deploy that first of all. So kubectl apply 0.1. And that's going to create all these resource definitions inside my cluster, which means that I can manage these Istio components through Kubernetes. And it doesn't deploy anything yet, it just creates the types of the objects. And the next thing is to deploy Istio itself. So the Istio YAML file, again, this is just a Kubernetes YAML file. I won't go into too much detail because it's 15,000 lines. So that's one of the reasons why I'm not going to go through this. The reason it's so big, actually, is you can put pretty much anything inside your YAML file. And one of the things that's in here that takes up a whole bunch of the room is a dashboard that Istio builds for you. All this JSON here is about how to represent a dashboard. So it's just baked into one enormous YAML file. So let's deploy that. So my custom resource definitions are there, and now I'm going to create all the things that are actually Istio. So this is going to be running all these containers through Kubernetes, which is Istio sat on its own. And until I start deploying applications, Istio is not going to do anything much. OK. So, as this is rolling on, so I've got now, if I show you what's in Kubernetes, so the Istio components live inside their own namespace. So if I look at all the Kubernetes objects, I don't see anything except the Kubernetes API. But if I go and look at the Istio namespace, which is called Istio system, Kubernetes lets you separate things into different namespaces, so you can just group applications neatly together. Istio provides its own, and this is all the stuff that's in Istio now. So there are a bunch of batch jobs that have finished. There's some horizontal pod auto-scaling, which is nice to have. There are replica sets, there are deployment services, and a bunch of pods. And these are all running as Docker containers. So if I do a Docker container ls, I'll see a whole bunch of stuff. And these are all the Istio components that are running inside containers in Kubernetes. Okay? So as of yet, I haven't deployed anything. Now, if I want to deploy an application now, I would have to manually register things with Kubernetes. So inside the application manifest, I would say this service needs to be registered with Istio. But instead of doing that, I can configure this auto-registration, and I'm going to do that just with a Kubernetes label. So all that does is say the default namespace. So if I deploy an application without a specific namespace, it goes into the default namespace. The default namespace now has a label applied, which is Istio injection enabled. So Kubernetes has this fantastic labeling system. It's just completely arbitrary key value pairs. You can apply labels at pretty much any level. And then anything that's running in Kubernetes can query the Kubernetes API and say, tell me the label value for this particular component. So that's what Istio is doing now. When I deploy a new application, it will get a notification from Kubernetes API to say a new thing's been deployed. It will check the namespace to see if there's auto-injection enabled. And if there is, it'll register those components with Istio automatically. So now I can deploy my actual application. So that's my one-off setup that's got Istio up and running. This is my application, which, like I said, I'm not going to go through the Kubernetes stuff. All there is here is a bunch of services and a bunch of deployments that are going to run the containers. So I've got a details service, which gets me the details about the book, and that's just going to run one instance of this container, this Docker image here. So it's the same for all of these things. The difference being the reviews service, there are 3 implementations. So with reviews, there's a single service, so a single host name called reviews that can be accessed by other components. But there are 3 implementations. So there's version 1, there's version 2, and there's version 3. OK, so they're all going to be running. And without me actually shaping the traffic, it will just randomly load balance between them. So let's deploy this application. So there's nothing inside my YAML file to do with Istio at all. This is just a pure Kubernetes YAML file, an application manifest with a whole bunch of microservices. There's nothing to do with Istio in here. But because I've set that auto-injection, all these components will be registered with Istio.
Question, how much memory have you given the VM?
6 gig. So the Docker desktop that's running Linux containers, it runs a virtual machine in the background. And you can configure how much memory and stuff it needs. The default is 2 gig. It ain't going to work with 2 gig. So let's go for kubectl F03. So that's going to deploy my application. And it will create all the Kubernetes pods. And it's going to run all the containers in the pods. And each pod will have a proxy sitting alongside it. So if I now go and look at my containers that are running, at the beginning here. So I've got a lot of stuff running here, and I've got things that are for my application here. So somewhere down here, I've got, where are we? I've got my reviews service. So that's my reviews version 2. The names are all auto-generated, so you can't really see them very well. That's the container that's running version 2 of my reviews API. And then up here, I've got a proxy for my reviews API. There's proxy for reviews 1, reviews 3, and reviews 2. So everything's got the proxy for routing the network traffic, but it's all transparent. My actual reviews API doesn't know anything about that. OK, so this is all running, which I can check with get all, which might take a moment or two. And of course, all the steps I've been running, deploying Istio, deploying my application, is exactly the same if you're running on a cluster with 100 nodes. You're going to use the same YAML files, the same commands to deploy it on AKS or EKS, or if you're running Kubernetes in-house, it'd be exactly the same set of stuff. So everything's up and running here for my reviews, for my application, but I can't send any traffic in yet. So everything's being managed by Istio, and by default, Istio won't let any traffic into my application unless I explicitly configure that too. And I do that with a gateway. And this is the component that's listening for external traffic, and it's going to allow that external traffic to reach my application. And again, that's just a Kubernetes deployment. So I've got a gateway here. which is a virtual service. That's an Istio component. So that's a custom resource that Istio is managing, but it's managing it through Kubernetes. So I'm going to deploy this Istio configuration just by doing a kubectl apply, same as I deploy my actual application. So Kubernetes is managing the Istio objects for me. Inside here, I've got some exact URL matches to say any requests that are coming in, I should push them to the product page. Of course, I can use wildcards. I can have different traffic going different places. But this is going to give me access into my application. So let's deploy the gateway. OK, and now because I'm running in Docker Desktop, it takes care of load balancers and stuff. So even though this is sitting inside a whole bunch of stuff that's being managed by Kubernetes with the networking looked after by Istio, I can just call localhost to get that. So if I look at the ingress gateway, which is the component that's taking external traffic into the cluster, I will see that it's a load balancer type, but everything's being run through localhost. So Docker Desktop, Mac, or Windows will just set that up for me. So now I should be able to browse to localhost/product page. And see my application. Yeah, OK, phew. That's the first scary bit over. OK, so this is working. So it's a single web application, but all the bits are coming from different services. So this is coming from details, this is coming from reviews, and these are coming from the rating service. This is showing me a text review plus a rating in black stars. If I refresh, I see red stars. So red stars are issued by the version 3 API, black stars are issued by the version 2 API, and no stars at all is the version 1 API. And I'm just getting, as I'm refreshing, I'm just seeing load balancing between all my API elements. So everything that's been deployed is all running. It's like I'm partway doing an upgrade of my application, but the load balancing is going through all the different available versions. OK, so that's the first thing. So now we've got that up and running. Now I can control it with Istio, but at the moment I'm not doing anything, so I'm just getting that kind of load balancing across all the versions. So having deployed this, the first thing I can do is start looking at traffic management. So use Istio to control where the traffic goes between the product page and these other bits and pieces here. Traffic management, because I've registered both sides with Istio, I can control the traffic pretty accurately. And there are a whole bunch of things that I can do to send the traffic to specific places. Now, this is the kind of the stack that it goes through when I'm calling into the review service. So that's the host name that I'm using. So inside my product page code, I'm just going to http/reviews. And then that's going to hit a virtual service, which is an Istio component, which has got a whole bunch of destination routes set up with a bunch of subsets. Now, I'm not going to go too deep into this, but what it looks like is this. I can set in a manifest that 50% of traffic headed for the reviews host should actually go to the version 2 subset. So version 2 subset is just saying, find the API deployment that's got a label of v2 and send all the traffic in there. And I can send the other 50% to v1 or v3. So I can send all traffic to one particular subset, or I can mix and match and send it around to different places. So like I said, there's a whole bunch of stuff going on in here, but ultimately it's enabling me to configure how the traffic gets from A to B and which version of B it's going to go to. So there are a bunch of things I can do with traffic management. So the first one is what's happening in production, what's happening in real time. So I can set things up so I've got health checks running by Istio. So not just a health check inside the container that's telling me the application's healthy. This is running from Istio that's checking that I can reach the network endpoints. So the application might be unhealthy, or the container might be unhealthy, or the node might be unhealthy. And Istio will be able to check all that stuff. I can do the load balancing, and I can do that in much more fine-grained control over load balancing than just doing a round robin. Istio lets you have different patterns of load balancing and setting up different pools. So I can have a pool of components that are in one data center and a pool that are in another, and I can send 90% of traffic here and 10% there. It does the retries. I can configure the timeouts. I can configure the more advanced retry logic and all that sort of stuff. The second thing is quality control. So in production, I can set up routing rules to say certain users should get a different response from everybody else. So I can say everyone who's using the site gets the version 1 API, except for a specific user who's a tester who's going to get version 2. So I can do a live deployment, but send no traffic there, except for certain users or certain groups of users or however I do it. And once I've got that personalized routing, not only can that user only see certain things, I can do fault injection, deliberate fault injection at the network level from Istio for that specific user. So I can test real-life failure conditions and make sure the app responds gracefully. And the last thing is deployment. Because I can manage where the traffic's going, I can do A/B testing. So if I've got two ideas of how a feature should be implemented, I can deploy both, I can collect the telemetry from both, and I can decide which one is the way to go forward with. And I can do stage rollouts and canary deployments or however you want to define them. So I release my new version of my app, and I send 10% of traffic to the new version and the rest to the old version. I can leave it running in production for as long as I want, and once I'm confident that the new version is working correctly, I can just up the ratio until eventually everything is going to the new version. So there are three real main areas where this traffic management stuff becomes really useful. And it's difficult to do this, all these features, without a service mesh. Like, there are different ways of achieving different parts of this, but you're going to end up bolting together lots of systems, whereas the service mesh lets you do it in a single, neat way. OK, so my demo. So at the moment, my application is just round-robining, it's definitely not a word, through all the versions of my API. So what I want to do, first of all, is just send everything to one specific version. And the way I do that is by setting up my routing rules. So inside here, I've got some more, it's all Kubernetes manifests. I've got a destination rule that I'm creating here. And this is saying for the host name called reviews, which is just my review service host name, there are 3 different subsets of places that the destination traffic could go to. And these are all just done with Kubernetes labels. So when I deploy my application, I have labels saying this is V1, this is V2, this is V3, and this is just telling Istio how to direct traffic to those different subsets. A subset is just an endpoint or a set of endpoints, and you tell Istio how to configure them. This is, again, this is all arbitrary. I could use any combination of things that I like. It doesn't have to be versions. It could be data center location, or it could be anything that you want to put in there. So first, I need to deploy that. So let's go to demo 2. And I'm going to do kube. Everything I'm doing is just with kubectl apply. So you only have to learn one command. So those are my destination rules. That's just creating the ability to send traffic to different places. And the next thing we do is actually put an implementation in there. So what I'm doing here is my virtual service for the reviews host, send everything to subset V1. So it's HTTP traffic. So Istio understands about different types of traffic, HTTP, Go remote procedure calls, and TCP. If it's HTTP, I can do interesting things with inspecting the traffic. But I'll come to that in a moment. I'm saying all HTTP routes to this destination go to subset V1. So when I do that, when I start browsing again, every single response, I'm hitting F5, every single response is coming from the version 1 API. So that's the version without any star ratings. So all the traffic's being directed to that one subset, which is ultimately going to a pod with a Docker container in there, which is version 1 of my API. So that's pretty simple how I'm managing this stuff. So I had to do a bunch of stuff to get here, but now the sorts of things I'm applying are pretty straightforward sets of rules. So the next thing I can do is I can say, if I'm a tester, I want to give myself a customized response so that I can see what's happening for a new release and test that it's all OK. So what I'm doing here, I've got another configuration for my virtual service. It's for the reviews service. When I apply this, it will replace the existing one. So currently, everything's going to V1. What I'm doing in my new deployment is I'm saying the default route for HTTP traffic is the subset V1. But I've got a match rule in there as well. And the match rule is saying, look at the header, the HTTP header on the incoming request. If there's a header called end user with a value called JSON, then this is a match, and this will apply instead. And this rule is to send all requests from JSON to subset V2. So this is I've done a live deployment of V1 and V2. No traffic is going to V2 yet, but I'm going to configure this so that one specific user gets my V2 response. So let's do that. OK, so there's no downtime here. Like, the application is all still up. I'm not having to change the config of my application. Certainly not doing a new deployment of my application. I'm just changing what Istio is doing with the rules. And it all just applies at runtime. So as an anonymous user, I always get the version 1. If I sign in as JSON, then I get version 2. And I will always get version 2 as I'm signed in as JSON, because that's how I've set up my traffic managing rules. If I sign in as a different user, Sign out and sign back in again. I will always get v1 because that's the default. Okay, so I can do this personalized routing, which is actually a really nice way of just testing that an application's, that the new version is okay, but it's already in live. So I can see it functioning in live. I can see all the monitoring and telemetry that I've got for the rest of my system. The other thing I can do once I've got that is I can do this fault injection. So what I'm doing here, this is the same virtual service for my reviews. The default route is still the same. I'm sending everything to v1. But I've got my match rule in here. So if the end user is JSON, then I'm going to inject a fault. So I'm still sending everything to v2, but I'm going to inject a fault. So for every single request that comes in, let me increase that, I'm going to put in a delay of 5 seconds. So for every single request that comes from another component that Istio manages into the review service, we'll have a 5-second delay applied, which is how I'm going to let JSON test that the application still works correctly. So when I deploy this, which is number 4, so my Amy user still seems the same response, and there's no delay. Everything's just working normally. If I sign out, then the anonymous user still sees version 1. Sign in as JSON now. And there's a delay here, which is Istio kicking in. It's an actual network delay. It's not simulated. It's stopping the network traffic for as long as I've said to. I do this for 100% of requests, but I could do it for a portion of requests. And I do get a response. So my application is handling the fact that it's timed out. It's waiting just for a couple of seconds, and then it's going to say that it's unavailable. If I go back and change this to a smaller delay, then I can verify that it's working correctly if there's only a small delay. And again, if I refresh this, it took a second or so in between refreshes, but my application can handle that much of a delay. So I can do pretty fine-grained, low-level testing in live with all the live environment and just make sure that everything's working as I want to. And because all this stuff is done through application manifests, I can automate it all too. So I can have an automated deployment, which is, it could do it as part of a nightly test or an integration test. It applies all these different rules, automatically signs in as different users, and makes sure that the app's behaving as I expect. So I can do some pretty complicated integration level testing and automate it all and be confident that changes are working as expected. So I won't go through and do all this, but you can also do things like abort the HTTP call and return a 500 status, and I can do that for a certain percentage of calls. So sometimes it will fail, sometimes it won't. I can see what's happening when I do that. And then finally, when I'm ready to start to do my deployment, I'm going to skip straight to version 3 here. I can say, here's my virtual service. It's for the reviews component. There are 2 routes, but there's no matching rules. So this isn't specific to one particular user. So 20% of traffic is going to go to my new version 3, and the rest of the 80% of the traffic is going to go to version 1. So this applies to all users, but I could have this sort of complex routing inside a match clause to only match for certain incoming requests. So the incoming request that I've used has been the end user header, but you can use anything, any HTTP header that Istio can get to. So when I deploy this, which is 6, so now any user is going to get this is like a canary deployment where only some traffic is going to the new version. So most of the traffic is going to go to version 1, so I won't see any stars, but sometimes I will get a version 3 response, which is my red stars. So I'm signed in as JSON now, my test user. If I sign out, I'll get the same behavior. So this is applying across everyone. So I'm not doing any kind of filtering across there. And then when I'm finally ready to do my full deployment, all I do is I just change that and remove all the weightings. So now for my virtual reviews, my reviews virtual service, everything's going to subset v3. And the way I'm doing these deployments, again, it's just easy, just kubectl commands. They're just YAML files, and I can automate all this stuff. So now every single user will get my version 3. OK, so back to the slides. How are we doing? OK, so the traffic management side, I've only done it within this component, but of course everything is registered with Istio, so I've got that level of control across traffic everywhere. And I haven't shown you the server-side rules, but you can do the server-side stuff as well to do rate limiting and throttling and all that sort of stuff. So I could put that right at the beginning with my ingress gateway and say, you know, I'm not going to accept more than 10 requests per second from this particular IP address. Or I can do whitelists and say only this IP address, which is my corporate IP address, has got any access at all. And then so nothing else can get in within there. Once I'm inside here, then the other big component of Istio is about the security of the traffic between these internal components. And again, with security, there's a whole bunch of things you can do. What I've actually, this is already running in my application. I'll show you that in just a second. But I've already got this stuff because I've set this up to be the default. So what Istio does, again, because it owns both sides of the conversation, it's encrypting this with mutual TLS. So it's using transport layer security, the successor to SSL. Each of these components has a certificate, and the certificate has a secure name, meaning that you can reliably identify who is sending the traffic from the name that's in the certificate. That secure naming comes from wherever Istio happens to be running. So if you're running in Kubernetes, it will come as a service account. If you're running somewhere else, it will come from however you're identifying the nodes where this stuff is running. Because I can securely name and know where information is coming from, I can do authentication and authorization. So the review service can be certain that a request came from the product page because only the product page has that certificate, has that client certificate. And I can also do authorization and say only the product page can make calls to the review service. So if the details page tries to call into reviews, then that will fail because that's not allowed. It's all based on the mutual TLS, the certificates that client and server have, and Istio manages all that for me. So it creates a root, a certification authority, and it mints its own certificates, and it stores them. So when any new component registers with Kubernetes, with Istio, it will generate the certificates, and it stores them, again, in whatever store is appropriate for where it's running. In Kubernetes, it stores them as Kubernetes secrets. So they live inside the cluster, and they get delivered to the container when it needs them. And the container is the proxy container. And they have a fairly short lifespan. So at the moment, it creates a cert with a 3-month lifespan, and it rotates it automatically for you. So we're getting security in depth here. So if someone manages to get access into your cluster, they can't send these requests without having a client certificate, which they have to have got from within Istio. If they do manage to get a certificate, it's only going to be valid for a couple of months before it gets rotated for you. So you're getting a lot of security without doing very much, which I'll show you, because I didn't do anything at all to make this happen. So this mutual TLS, I've already set that up to be a default policy inside Istio. So this is, again, it's a Kubernetes object. It's called a mesh policy. So it applies across the entire mesh. And it's a default saying, it's a bit cryptic, but it's saying the specification is between peers, there will be mutual TLS. And there's nothing else in there, which means Istio will manage it all. I can put other things in here. So if I've got my own root certificate authority I want to use, and my own certs and keys, I can put that stuff in here too. But this is the default. And I've deployed my Istio configuration. So when I did my very first demo and I deployed Istio, I've set that up to be the default. So I can see that with, if I describe my mesh policy, I can see, again, it's not, unless you know what that means, it doesn't really tell you very much, but it's saying all peer communication will be secure with mutual TLS, and that's all I need to do. Anything that gets registered with Istio, any traffic that happens through Istio is going to be encrypted. So what that actually means is, with the mutual TLS, is that if somebody gains access to run binaries from my application, so they manage to break out from my web app, and they can run binaries on the server is actually a container inside a pod, and the network communication is going through Istio. So there's a limit to what they can do. So if I go and find this a container, hey, there we go. So this is the proxy container from my product page. So again, this is the Istio managed container, but it's just a Docker container. The fact that it's running in Kubernetes with Istio, if I can get access to the Docker API, then I can kind of subvert all that stuff. So I'm going to get the ID of that container and run some commands. Oh, no, I need to do it this way. So that's just got the container ID to make it easier for my subsequent commands. So I can do this. I can try, if I manage to find out a little bit about my product page, and I can see that it's talking to the reviews page, if I'm inside the container, then I can try and do a curl and get to the details for any application. Because I can see, if I can see the code for the application, the product page, I can see that it's going to this URL for the details. Now, if I try and do that from within inside the container, I get this 56 error, which is telling me that this should be an HTTPS call. So if I know my curl responses, then I know that it's not going to connect because it should be HTTPS. So if I go back and change this to HTTPS, and thinking that I'm going to get somewhere now, I get a 77, which is also really useful. It tells me there's no client certificate. So it's not just an HTTPS site where I can go and connect. I need to have a client certificate that the destination is allowing me to use. So if I want to actually do this, I need access to the proxy. I need to get myself inside the proxy container, and then I can run a command like this to say, curl the details service, and these are the certificates that you need. I need access to those. So I've got that because I'm a Docker admin on this box, and I can finally make this call. But in order to get there, my attack surface is now really minimized because I need to be able to get access to the cluster, I need to get access to the container inside the cluster, and then I need to get the certificates from somewhere. Okay, and even if I do manage to do that, I can't get that information back out from the container. So if I try and make an external network call from an Istio managed container, it's blocked by default. So if I could curl this and save it into a file, I couldn't then post that file somewhere else. Okay. So the security side of things, it does an awful lot for you for free. Again, because it's managing both sides of the conversation, it's using standard libraries for all this stuff. It just uses OpenSSL. It uses the techniques that are used on the internet, so it's not using any sort of custom homegrown security. It's it's tried and trusted TLS stuff that's been used for a very long time. And the last thing I'm going to cover is observability. So again, everything's under control of this single thing, this single control plane of Istio. And it's not just being used to push configuration out and to do the security, it's also constantly monitoring everything that's happening between these service calls and the clients that are making them. And you can plug into all that stuff and see all sorts of details from what Istio is collecting. What you actually can see depends upon how you've deployed Istio. So I've deployed it with a bunch of dashboards that are already available. All I need to do is enable access to them so I can go and see the dashboard. Starting with visualization, so I'm going to be able to see all the components in my distributed system, and I can see the traffic flowing between them, and I can see at a high level things like requests per second going in from one component to another. If I want to go down to the next level, then Istio is also collecting tracing calls. Now, I need to give it some help with that, but the demo app has already got that code in there, just to be able to tie together these calls so that it knows that a particular call to the review service has come from a particular call to the product page, and it can tie all those things together. But then I can see a nice little dashboard that will show me like a heat map of how long individual calls are taking, and I can drill down and see that, to respond with the product page took 1 second, and half a second of that was from the review service. And then I can go down to monitoring, so I can show a dashboard about Istio itself, how hard all the Istio components are working, how much memory they're using, how much CPU, what's actually passing through Istio. And if I really want to, I can go down to the logging level. So I can tell Istio, I've already got some logging stuff running, so I want you to record a log entry for every single bit of network communication. And then I can use whatever logging framework I like. I could use Elasticsearch and Kibana, and I could be able to drill down into the individual logs. Okay, so let's show you some of that stuff. So again, the way I deployed Istio, a lot of these things are already deployed for me. So if I go and all I need to do is make them available. So there's a component called Service Graph, which is going to give me that overall visualization. It's already running, it's on port 8088, but it's not publicly available. And because I'm an admin here, I can just make that available to me by forwarding the port. So that's going to be fine. And now I can browse to my local host, and it will send the traffic in there. So this is it's an open source component that Istio kind of lets you bundle in, and it's just recording. It flips around and moves around, which is really good fun, except when you're trying to actually get some information from it. This is all the bits of my application and where the traffic could potentially go. So this is showing me that my product page could go to, it's got a connection to client for reviews v3, v1, and v2. So again, this is all coming from being able to introspect what's happening inside Istio and what's happening inside Kubernetes. If I click on this, then I will get the kind of high-level information about where the traffic is actually going. This is real-time stuff, so it's all 0 at the moment. If I send in lots of refreshes, then I should see these numbers start bouncing around. So the ingress gateway is the thing that's bringing in traffic from the outside, and I can see that I've got requests per second coming in here. There's nothing going into version 1 and version 2, because I've configured all traffic to be version 3. So it's a nice way of verifying what's going where at any particular time. It only gives me that high-level view, though. So the next level is to do the tracing and see where the traffic's going in between components and where the time is being spent. And again, this is already running. So Istio uses a component called Jaeger, which is a dashboard that shows you traces in between components. That's already running, so I just need to make it available. Of course, if this was production, I'd put all these things behind some sort of proxy component, so I would have authentication, and I'd be able to view it from wherever. But I'm right here, so I can just browse to this port. That's not going to work, is it? Let's do localhost. Is that right? No, that's why. OK, so this is Jaeger. Again, open source thing. It's part of the Cloud Native Foundation. It's a way of visualizing traces between components. That's pretty much all it does. It already knows about these things because Istio has been collecting all the traces. It's just all I've done is enable access to the UI. So I can go and look at these results. And it's going to show me that some of these calls have got errors. Each of these is an individual call coming from the outside into my product page. If I click on one of these, I get the drill down telling me where the traffic is going from the gateway onwards. So the ingress gateway sends traffic to the product page, which makes a call to the details service, and then makes a call to the review service, which then calls the rating service. And I can just see all that without having to do kind of anything much at all. And I can drill down here, and I can look at the tags, and I can see the URL that was requested, the response code, the response size, all sorts of interesting stuff here. So I'm getting a pretty good level of detail about what's happening. And if I've got some other tags in here, which I can put my own stuff in, so I've got a request ID in here, which is just randomly generated at the top entry level, and it's passed on through all the other components. I could have, if there's a problem, I could throw that up on the error page. And then when a user phones up and says, I've got error A7EB, whatever they say, then I can tie that into this specific trace. And I can see maybe the review service bombed out after 5 seconds or whatever. OK, so that's my next level, which is tracing. Again, don't have to do anything much for that. I do need to tell Istio how to piece together the stack. So all it knows is that a review service call was made and a product page call was made. It doesn't know they're part of the same transaction. So to make that happen, I need to flow through an ID, which I've got in here. So this is the sample code, again, all on GitHub. I'm specifying a request ID in each of my components. So at the entry point in my product page, I generate a request ID, and I attach it as an HTTP header. And then all the other components, they just relay that. So there's an incoming request ID. They add that to their own payload. And then Istio pieces all those things together. All these other weird things, the XB3, they're all things that you can add to Istio to increase the amount of visibility you get from those calls, just tying the things together. OK, and again, that's optional. You don't have to do that. But if you just add those headers, then you get all this rich level of telemetry that can tie your service calls together. OK, and then the last thing, if I show you the actual runtime performance of what's happening inside my system. So this is Grafana. So Istio is running Prometheus, which is a metric server. So it's pushing all this stuff into Prometheus. And then it also runs Grafana, which is a dashboard that shows you what those metrics look like, with a whole bunch of pre-configured dashboards that I can just drill down into. So if I go and look at my Istio, I can look at the service dashboard. And that's telling me for each of the services what's happening, number of requests per second, and all that sort of stuff. I can see my Istio. I've got a mesh dashboard here, which tells me everything that's registered with Istio. So I've got my review service and my product service and all that sort of stuff in here, telling me where the traffic's going between them. And I can drill right down and look at things like Istio workload, which is telling me traffic that's coming in, how hard Istio is working, and the fact that these things are secure with mutual TLS. So I can see at a very high level and then drill right down. And I can even, if I want to, I can go and see how hard the different components of Istio are working. So if I want to go and look at, let's see, where's Pilot? Pilot here, this tells me how hard. Pilot is the component that pushes configuration out to the individual proxies. This is telling me how hard they're working, how much memory they use, how much network, all that sort of stuff. So I get a pretty good idea. If I think there's a performance problem, and I think it might be Istio that's caused it, I can drill down into all this stuff. And I'll probably find that it wasn't Istio. OK. And the last thing I can do is logging. I'm not going to show you that demo, but I could, if I'm running Elasticsearch, I just need to set up a component and deploy a rule, something like this. So I can create a Kubernetes object, which is a log entry. and that will tell Istio that every single request that comes through to log an info request with all this detail and to push it onto FluentD, which is a component that can load data into Elasticsearch. So if I had Elasticsearch running, which I could deploy as the Kubernetes deployment, then I can tell Istio to record a log entry for every single piece of traffic that flows through. And then I can query that with however I want to. So I can get an awful lot of detail without doing very much work. I don't have to write all these, I don't have to write code to say I'm about to call the review service at this timestamp, and another line to say I've just called it at this timestamp. That's all network level concerns. So I can do that with my network infrastructure. Okay, so traffic management and security and observability, I was focusing on the middle part of this application, but because everything's in Istio, I can do that with all these components. So if I wanted to, if I had different versions of my product page, I could do traffic management to shape between them. I can make sure there's security across all these layers. If I had a separate database, which is running on a virtual machine, then I could deploy a proxy component on the virtual machine, and I could include that in the mesh. So I could use, and if I wasn't even using Kubernetes and just had a bunch of virtual machines, I could install Consul, which is an alternative way of deploying a service mesh, and put Istio on top of Consul. So Consul is just the agent that lives in all the VMs, and it does the proxying for me, and I can deploy Istio on top of it, and I can use Istio to manage a whole bunch of VMs instead of a bunch of containers. Okay, so that's all pretty good stuff. There is a learning curve, depending on how far you are on the Docker Kubernetes curve. And there are different ways of doing this. So if you need some of those features, it doesn't necessarily mean you need a service mesh, because you can do things different ways. So all the traffic management stuff, actually, you can probably get a lot of what you need through DNS, through shaping traffic through DNS, or through feature toggles, or with some sort of client library that says, I'm going to send some traffic here, I'm going to give different users different responses. The trouble is you're going to be cobbling together lots of different things, and you are not going to have a single entry point to control everything. And you will need this in every client where you want that sort of functionality. Same goes with security. So you might get some of the security, the encryption of traffic, you may get that from your platform. If you're running in the cloud and you're using a PaaS service, there may already be that stuff for you. If there isn't, then you can do it yourself with some sort of open source component. Don't ever write your own security code, obviously, but you can use the same sort of components that Istio is using to do that for you. It's not easy, because you need to think about certificate rotation and storage and all that sort of stuff, but you can kind of do it. And then observability, all those dashboards I showed you, they're all open source components. You can put your own telemetry into your own services, but again, you have to add that logic to everywhere where you want to expose it. Whereas because everything's being routed through Istio, you can have a central place to manage all that stuff for you. So do you need one? Well, there are some good markers of where you're in a problem position where a service mesh would probably help you. So if you've got millions of services and you don't know if they're being used or how well they're being used, and you really could benefit from that telemetry view that shows you the span of network traffic, then actually, if you're already running in an environment where you can apply something like Istio, then you're going to get an awful lot of benefit from doing that. If you can't do a release, if you're not confident about doing regular releases, then actually having a service mesh in there that lets you do the release during office hours, but not send any traffic there, and then gradually send traffic in on the live system to specific users who want to test a new feature or make sure that everything's working correctly, you can build up that confidence that we can do regular releases. And if you can put all those sorts of logic about testing those use cases for failure into your release pipeline, then you can be confident that unusual conditions are handled correctly too. If you've got all those sorts of dashboards, like the Grafana dashboards and the Kibana for your logs and all that sort of stuff, and every project's got its own, then consolidating them all within an Istio set of dashboards is going to give you save you an awful lot of trouble. Because you can still filter them, so project A only sees its own data, but you're storing them centrally, which means you can then aggregate and do all sorts of other interesting stuff. And if you're thinking of doing this anyway, if you've got a brand new application and you've decided you're going to write it to be container first, so everything's going to run inside a container, and you're going to be using Kubernetes because you were told to, and if you're doing that already and you've already made that decision, then adding Istio onto the end isn't a very big increment. You'll get all those benefits and you won't have to do an awful lot of extra work if you've already committed to go that far. But you need to think about the fact that it's going to be costly in different ways. And you need to be aware of that when you take this in. It's still a fairly new technology. The companies who are using it are the big companies who are doing internet scale stuff. It's all available for everyone to plug into their systems, but you need to think about what it's going to cost you to get there. So firstly, there's a lock-in issue. Not necessarily with the technology. So like I said, Istio has the biggest feature set right now, but assuming that service meshes have a longer life than a few years, there will be more that appear that can do the same thing. But it's more about an architectural lock-in. If I'm depending on having a service mesh, then I'm not putting any of that communication logic into my application. So all my components are just talking to HTTP/whatever. There's no SSL in there, there's no traffic management, there's no security, there's no observability. I'm relying on the mesh to do all that for me. And then if I decide actually the service mesh is too complicated, or we've decided that we don't want to use it, or there are a whole bunch of issues that emerge, I've got to go back to each of my components and plug that stuff in. So it's going to be costly to do that. The learning curve I've already mentioned. So Docker, you can get up and running with Docker in a couple of days. That's not complicated. Kubernetes is another step. You're going to have to invest some time to become a Kubernetes master. And you don't really want to start using Istio until you're pretty comfortable with Kubernetes. And then once you've learned all that stuff, then there's the debugging curve as well. When something goes wrong, where do I go? If the communication fails, is it an Istio problem, or an Envoy problem, or a Kubernetes problem, or a Docker problem, or a my code problem? There's a lot of extra stuff in there that you need to dig through. And then on a more kind of operational problem, because there's all this stuff, not necessarily everyone in the team is going to deploy everything when they're building the software. So if I'm a web developer, I'm happy running a Docker container. I don't want to be doing a whole bunch of Kubernetes and Istio deployments to test my latest UI update. So I may only run a Docker container. And then in my test environment, I've maybe got a single node Kubernetes cluster, and I'm not running Istio. And then in my full production environment, I've got multi-node Kubernetes cluster with Istio applied. Everything's different. And I'm not getting the consistency between environments because of the complexity of having these extra components. So that's something to bear in mind. And the last thing is, it's not very DevOpsy if it's so complicated that only certain people can do it. So I've got my DevOps team that build the product and run the product, and that's cool. And then everyone in that team can do everything, except for the fact that there's only one person who understands Kubernetes. So only one person can do a deployment. And you need to bear that in mind, because you're going to end up with your DevOps team with a tiny ops team inside it, which is just one person. And that's not actually going to help you get to where you want to go. OK, and the last thing I'm going to follow on with is so that these technologies here, Docker, Docker Swarm, Kubernetes, Istio, they all do different things, and they're all part of this kind of cloud-native new way of doing applications, which is actually really exciting and really interesting. You will sometimes see these presented as a timeline, as an evolution, and that if you're on the left-hand side, you're doing something wrong, and you need to get to the right-hand side as quickly as possible. That's not the case. So if you're running something in a virtual machine right now, a single virtual machine, if you move that to a container, you've got benefits. Things are definitely going to be better for you. You can move it anywhere. You can run it in the cloud. It could still be a big old monolith, but just being in a container is going to have benefits for you. If you need scale and failover, you can go to Swarm. If there's something that Swarm doesn't do that Kubernetes does, then you can use Kubernetes. And if you really need the service mesh features, then you can adopt Istio. But it's not if I'm down here, I'm doing something wrong and I need to progress. OK, so next steps. There's a whole bunch of stuff on layer5.io, which is curated by one of the Docker captains, a guy called Lee Kalko. Really interesting stuff there. If you're still at the early stages, then on Pluralsight, there's a Docker learning path with a whole bunch of from intermediate through to advanced stuff there. And then there's Kubernetes stuff on Pluralsight too. All today's demos are on GitHub, so you can go and all you need is Docker Desktop on Windows or Mac, and you can replicate all this for your family at home. And then if you want to come to San Francisco in April, then I'll be glad to see you there for the big Docker conference. Please remember to do the voting thing on the way out. Hope that was useful. Come and see me if you've got any questions, and thanks for coming.